This topic is the ideal gas laws, or maybe it should just be the one ideal gas law. PV equals nRT is the familiar looking ideal gas law, but historically it was originally based upon Charles' law, Boyle's law, and the law of Gay-Lussac. There's some interesting history you can read about how these were named. It turns out some of these were maybe not actually discovered by the person that it was named after, but nevertheless, these are the names that are in modern textbooks. And you can look at each one of these and understand them. Like when it says for Charles' law, volume is proportional to temperature. That's assuming that pressure is constant. And if you look at the formula PV equals nRT, if P is a constant, N is the number of moles of gas. So that's kind of like how we define the system, you could say, for an ideal gas. Consider this many moles and doing whatever it's doing. But generally speaking, that's going to be a constant value that's connected with the defined system of gas that you're looking at. And R is the ideal gas constant, which by its very nature is a constant. That means if pressure is constant, the only two things that vary are volume and temperature. And since there are no exponents here, it makes sense that one is just directly proportional to the other. Boyle's law, you have temperature is constant, but that means pressure times volume is equal to a constant, which can be interpreted if you divide, say, both sides by volume, as pressure is inversely proportional to volume. And then there's the law of Gay-Lussac, which says that pressure is proportional to temperature, and that winds up being true for constant volume. That was the one that actually kind of came up in those early thermometry experiments where there was some trapped gas, and we were tying the amount of pressure measured by a manometer to the temperature of that gas.